Fasag, and this is my application problem regarding the optimization of second partials. So this is our problem here. A company produces two products, X and Y, and their total profit PXY is modeled by the function PXY equals 20x plus 30y minus 2x squared minus 3y squared minus xy. Find the values of X and Y that maximize profit, with X representing the product A produced in hundreds and Y representing product B produced in hundreds. Sorry. So in order to solve this problem, we have to find the critical points. And to find the critical points, we have to find our first partials for X and Y, which is exactly what we do here. So for our first partials for X, we have 20 minus 4x minus y. And for our first partials for y, we have 30 minus 6y minus x. And to really find the critical points, what we would usually do is solve for one variable. Like, for example, we have this problem, we would solve for y. But since both variables, x and y, are in these equations, both of them, we would have to eliminate one of them in order to solve for one of them. So that's exactly what we do here. So what I did here was multiply this bottom equation by -4 to get this negative x, to cancel this -4x out in order to solve for y. So multiplying this equation by -4 gets us -120 plus 4x plus 24y, which would effectively cancel this x variable out to leave us with 100 plus 23y. And from here, we can solve for y, which is exactly what we do here. It says 100 here, but it should be -100. It's right here. So -100 plus 23y, you just solve for y. You get -100, get it to the other side, and then divide both sides by 23, and you should get 4.35 as your y. And using this y value, we can plug this back into this equation right here to solve for x. So that's what we do down here. So for 20 minus 4x minus y, I just subbed in 4.35 for y. And I combine like terms. And then I isolate the x, divide for both sides, and I end up with 3.91 as my x. So our critical point would be 3.91 as our x and 4.35 as our y. So to actually determine if this point is a maximum, we have to put it in the second derivative test, which is d equals fxx fyy minus fxy squared. So to solve for these, we would have to find the second partials for these two equations. So our second partials for x for this equation would be -4, and for our second partial for y for this equation right here, we would get -6. And for our second partials for y for this equation, we would get -1, and same thing for fy of x, or second partials for x for this equation. we would get -1 as well. And just plugging these values back into oh, I forgot to mention, notice how I have xy, fxy, and fyx here, but if it is just fxy squared, uh, fxy and fyx, if the equation is uh, has no breaks, then they would just be equal to each other, which is why it's just fxy squared. So yeah, moving on, just plugging these into this equation, we would end up with 23, which is a maximum. And to actually determine if it's a maximum from this value, uh, so yeah, so 23 is our value for D, which means that D is greater than 0, which means it's either a local max or minimum at this critical point right here. And to determine if it's a maximum or minimum, we have to look at the our fxx. So our fxx is -4, and if our fxx is less than 4 or less than 0, or basically a negative number, then that means our value is, or our critical point is a local maximum. So yeah, our point is a maximum since this is greater than d is greater than 0 and our fxx is negative. Yeah. And if you wanted to find the actual value for the maximum profit, we would just plug this point or these points back into the original equation. So if we were to do that, we would find that the maximum profit would be $10,435. Yeah.